So we have already discussed about when should we use parallel stream, when should we go for sequential stream. In this example, we are going to take some processing to do with the use of sequential stream and parallel stream, and we will see for what size of data the sequential stream performs better and when parallel stream performs better, right? So let's see, we have some list of numbers, so list of integers. So let's say we have integer list, let's call it as numbers, and create an array list of it, and let me import this. So here what I want to do is I will just add some, let's say 10,000 numbers into this list. Okay, so let us run this loop for 10,000 times numbers dot add I. All right, so I'm adding 10,000 numbers starting with 0 till 9,999 to this list, and from this let us create the factorial. So we want to create the factorial of each number. Okay, now to track the time consumed by a certain process, we have nanotime method in a system class. So let's use that. So system dot nanotime. Okay, and let's say this is stored into a local variable. So press Alt Enter, it will introduce a local variable, and this is our sequential stream start time. All right, and then we are going to call the method factorial, right? So numbers dot stream, and then let us map to long, because factorial can return long. So map to long, and then from this class itself, so let's create a class in the method in this, give a name like perform calculation. All right, and this method we are going to create, and finally let's say we want to take a sum of it. Okay, so hover into this, create a new method. Now in this method we are going to take factorial of all the numbers. Okay, so let me take it as int, and this is a number we are passing in the loop. So long fact is equal to 1, just we have to write the simple for loop to calculate the factorial, and this is going to run for less or equal to the number, and then fact is equal to fact into I, and finally return the factorial. All right, so this is the factorial calculation we are going to do for all the numbers present in this integer list. All right, now after this factorial calculation is done, let us store the time. So this is going to be our end time, and then we will take the difference and we will say this is our sequential stream execution time. So this is our execution time, and it is equal to end time minus start time. All right, and let us print this. So sequential stream execution time, and let me put all right, and the same thing we are planning to do for parallel stream. Okay, so what we will do is, let us say this is for parallel stream start time and this is parallel stream end time. Now here what we need to make, this stream has to be a parallel stream, so only this we need to do, and this is parallel stream execution time. So end time minus start time, and finally this is to be printed out. So I hope the program looks good. Let me save this and run this. Alright, so you can see that sequential stream takes lesser time, right? Lesser time than the parallel stream. So 1.5 into the 10 to the power, it will be 2 to 4, 6, 7. And here 2.3 in or 2.4 it will be into 10 to the power 2 to 4, 7, right? So this is going to take almost 50% more of the time, right? In this case, let me increase this 10,000 to 100,000 and let me save and run this. What happens now? So it will take a while. Still the this is parallel stream, so let me change the message. So the parallel stream is still taking more time, right? So let me increase the data set again by one more 0. So it is power of 6 now, 10 to the power 6. Let us see. So it's still more. Let me increase still more. So we will find a threshold where parallel stream starts performing better. Okay, I just want to find that. Now it is the time. See this, parallel stream has performed better than, slightly better than the sequential. Not slightly, it's still more because from here there's a difference, right? So let me increase by one more. And this is going to take a lot more time probably to execute because there is a lot of processing to do, for 10 to the power 7, right? 8 basically, 2 to 4, 6, 8, 10 to the power 8 we are performing this factorial calculation. So you can see here there is significant drop in the time. So it's basically 1/3 of what we have in case of sequential stream, right? So this is the advantage of parallel stream. When there is a huge data set to be used and we have certain operations, certain processing to do, then parallel stream performs better, right? So I hope this example was interesting for you, and accordingly you can do some more. You can create your own method of certain calculation, and then you can test for what data set sequential stream works better and for what data set parallel stream works better. Okay.